Good morning. My name is William Malik. I'm Vice President of Infrastructure Strategies with Trend Micro. In the course of this conversation, we're going to discuss two concepts. One that's been around for a while, which is cloud computing, and particularly from the aspect of its security, and the other, which seems new, but actually has elements that date back 20 or more years, and that's zero trust. The two of these come together in an important way for organizations that are migrating to cloud. So what we're going to cover in this talk is, first of all, what zero trust is, then what hybrid cloud needs from zero trust, the kinds of things that zero trust doesn't do, and those things that hybrid cloud doesn't need. We'll take a look at edge computing, 5G, and other factors that are going to bring extra stress to bear on the zero trust environment for cloud. And finally, we'll come up with some recommendations. But before we begin, I have a little fable. This consists of a story of two watchmakers. Tempus makes a watch with 1,000 parts, and Hora makes exactly the same watch, also with 1,000 parts. Tempus doesn't really structure his work. Tempus lays the parts out on the bench, and he begins to assemble them one by one. Hora, on the other hand, has structured her work, and what she does is she'll take 10 pieces and construct a sub-assembly. She'll do that a number of times, and if she gets 10 sub-assemblies, she puts them together into an assembly, and when she gets 10 of these assemblies, they snap together to form a watch. Now, here's the problem. They're both quite popular, so they get phone calls from people wanting new watches. They want to commission a watch. And so they get calls at random intervals. And the problem is that when the call comes in, they have to put down what they're working on. And at that point, it falls apart. So when Tempus gets a watch done, he has a very, very significant chance that that process is going to not succeed. Whereas with Hora, when something goes wrong, she's going to put it down and lose at most 10, more likely 5 parts. The difference is if they get one call in 100 while they're working on it, it will take Tempus 4,000 times longer to get the watch done. For every watch Tempus completes, Hora will have completed 4,000. This analysis comes from a work called The Architecture of Complexity by Herbert Syme. It was published back in 1962. Very useful piece generally. It's included in the references, which are at the end of the document. So let's get into the body of the material. When you are doing anything with cloud, there is always something left that you own. You can't get rid of the whole business. If it's infrastructure as a service, it's just about entirely on you. You have to put it all together. At the other extreme, if it's business process as a service, you as the consumer of that service are going to have to monitor the service level compliance and make sure they're doing it. In other words, it's not fire and forget. You always own something in the cloud. You can't offlay all responsibility. We're going to focus specifically on the security aspects. So let's begin by examining what zero trust is. The concept has been around, as I said, for a few years, but the basics of it have been around for quite a while. In the late 1990s, there was a concept called network access control, or NAC. The idea behind NAC was you cannot just join a network because you have the name of the network and some basic authentication. You actually have to pass a test on the way in. Georgia Tech has an open network. Anybody can find the ID and attempt to log in. Even if you have a user ID and password on the system is going to take a look at your machine and determine whether or not it's safe to let that machine on board. It's going to take a look at your OS updates. It's going to take a look at your antivirus. Do you have one of their recommended products? Has it been run recently? Are the signatures fairly current? If you don't pass those tests, you don't get on the network. You're going to be put into an anteroom so that you can correct those issues before you'll come on board. So network access control brings up the notion that not everybody who knows how to get into a network should be in the network. The other core concept behind zero trust is that you don't want to believe in a perimeter. You don't want to rely on a perimeter. The old concept was, if I know how to get into a network, then I must belong there. Well, the notion of a perimeter is obsolete. And in the late 90s, there was a group called the Jericho Forum, which was built on the concept that the notion of a wall is bad. In fact, this illustration is Joshua at the Battle of Jericho. And the Jericho Forum was a strong force for the notion that there are no walls, you can't rely on walls, they're not dependable. So zero trust combines these concepts. The cloud doesn't have a perimeter. There is a source of trust, and you have to apply to that source of trust to get permission to access information within that. You assume a minimal need to know, you force separation of duties, you log everything that happens, and you want to make sure that people authenticate themselves, which means in most cases, if it is a critical task, you're going to want to use some form of multi-factor authentication. NIST has a document on what general access control for cloud systems is that talks about zero trust. Here's a comparison of the philosophies more conventionally described. Traditional security model, anything that is inside the perimeter, anything that is on the network is, by virtue of being there, trusted. We're going to assume that the identities of the people who come on board are correct. They have not been compromised. Zero trust, on the other hand, would say, I want to verify everything. Sometimes that means you're going to have to re-authenticate yourself. More conventionally, there's going to be a baseline set of controls, and then there are specific risk-governed controls that will play when somebody wants to get on board a network and use a particular resource. The traditional security model is that all users are responsible, they try their best, they're going to do the right thing. The zero trust philosophy says, no, we're going to only allow people on there who've got specific permissions, who have a need to know, if you will, that's established either beforehand or is approved on a case-by-case basis as needed. And whereas traditionally we try to detect erroneous behavior, in a zero trust world, we actually work to make it harder for the bad guys to make progress. So what does hybrid cloud need from zero trust? Well, the basic fact is that cloud is a mess. There are a lot of things going on, especially with the pandemic and the vast surge in people who are working from unconventional platforms. Too many tools, compliance continues, DevOps is increasing the rate of change, cloud infrastructure services are here, there, and everywhere. And this is one of a set of pain points that cloud hits. Now, the reason I emphasize hybrid cloud is that very few organizations use just one cloud service. Many will use 2, 3, or more. They'll use public commercial ones, as well as in some cases community ones, and some cases internal cloud programs. But when you do this, regardless of which form, you're going to find the following concerns. You want to make sure you know who's doing what. You want to govern that. You want to audit that, which means there has to be logging. The change in release process described in ITIL hasn't gone away. DevSecOps has put it under a certain amount of stress. And so you need to make sure that your development process incorporates the goals of change management and release management. Change management says, I don't want unscheduled, unapproved changes going into the system. Release management means when we decide on a schedule, we've got to stick to that and make sure that the components necessary for it to go are in place. These things are comfortable with Agile, except in some pathological cases where Agile is just a new nickname for scope creep. But if you're actually got a goal in mind and you actually are tuning yourself towards that goal, eventually you will have a release plan in place. The information security specifics related to cloud, zero trust and identity management. Identity management because from a perspective, zero trust is essentially identity-based security. I want to know who you are. I want to know what resources you're going after. I want to know what the resources are, how they are expected to be used. Another issue for information security concerning cloud is shadow cloud. Shadow cloud is cloud that comes into the organization without your knowledge. You didn't know you were buying cloud. You stand up, say, some iTunes functionality, And the next thing you know, you've got iCloud connected to your machine. It's so cheap that it can show up unbeknownst to the user, but it still is an attack surface. And the third concern with cloud is the issue of garbage collection. And this actually comes to play when we start stressing certain functions of cloud as a result of 5G, and I'll get into that later. Other pain points for cloud: procurement, contract administration. Are you getting what you pay for? Are you being properly billed? Is the way in which you're acquiring cloud technology, whether fundamental infrastructure as a service or more complex SaaS-based applications, are you in fact looking at the right things when you make those purchase decisions? Performance and capacity management are still concerns. You don't want to just simply overbuy for the sake of just in case inventory. You want to allow the elasticity of the cloud to work in your favor, but you still have to be able to do some kind of planning for budget purposes as to what kind of expense rate you're going to see. Finally, there are organizational challenges going to cloud. When you go to cloud, you as a corporation have made a decision that it is less expensive to rent computer space than to pay for it flat out and then manage it and depreciate it over time. The problem that has organizationally is your people also are an expense, and they become more expensive over time. The cost of benefits, salary increases, promotional increases, all of these mean that a full-time employee is going to cost more, and you can project it. You know how much that's going to go. And the organization members know that as well. So if I'm working in the data center and we go to cloud, the thought will occur to me, are they going to downsize me? Am I going to be replaced by a less expensive contractor? Am I going to be outsourced? And how you manage that is an interesting challenge organizationally. You have to make sure you don't get rid of key skills that you're going to require at some future time as your environment changes yet again. So why does cloud need more security than the traditional data center? Well, it has to do with the fact that the cloud introduces additional attack surfaces. There are new vulnerabilities that come with cloud. There's malware that resides on and exploits cloud capabilities. There's the insider threat. And by insider, I mean not just the people, but the applications and the things that are dragged along with shadow cloud and shadow IT generally that can pose a risk. Network attacks are, of course, persistent. Cloud gives you another dimension of network attacks, another set of external links on the big I internet. And compliance concerns remain. There are, of course, a range dealing with the geographical location of information. If you physically owned the disks on which the information is stored, you knew where they were. If, however, that information is now cloud-based, how do you know where it is? The concerns say Germany does not want the data on German citizens recorded on devices that are outside of its geographical range. Most countries have something like that. The state of California is pursuing legislation that require personal information of California residents remain within the state. These additional compliance requirements not just have to be followed, but you have to verify that they're being followed. So what does cloud need from Zero Trust? Well, identity management is crucial. In fact, identity management is a prerequisite for cloud. You should have a comprehensive identity management solution in place in order to do cloud, and it should be extensible enough to deal with future capabilities that would include the identity not just of people, but also of subjects, of actors, of functions, of services, in some case of devices as you go forward. The network itself is a platform, and Zero Trust network access is a sound way of doing it. The prerequisite for that is network segmentation. Flat networks are an invitation to malware to traverse the environment. And of course, shadow cloud, the unexpected presence of cloud resources that were not booked, that did not go through normal procurement, they represent a space. And the cloud access, CASB, the cloud access security brokers, can assist with that. Now, there are some things that Zero Trust doesn't do, and some things that hybrid cloud doesn't need We'll go through these in the next couple of slides. Among the security challenges in the cloud, compliance, purchasing, the DevOps process, and the speed with which it updates the environment, these things are not directly addressed by Zero Trust. Now, Zero Trust can help with visibility. It'll tell you what's going where and who's involved with what. It facilitates DevSecOps because the Zero Trust environment can apply effectively in the development scheme and therefore port with it through your CDCI process into the production environment. Purchasing is going to remain a process. Purchasing is going to remain something you need to govern on a person-to-person basis. You need to put rules in place and then verify that they're being followed, and that is not something that's going to be handled technologically. When you are building cloud, you have either cloud native environments where you're standing up things from scratch, and you want to include Zero Trust as part of that environment. The DevOps process, the SEC in this case is silent, will include information security capabilities. Also a good place to talk about privacy, various access rights. On the other hand, in an environment that is not going cloud native, but wants to use cloud effectively, we have the whole cloud operational excellence domain. Here we're looking at governance and effective compliance. And there we want to put metrics in place that are meaningful to the business. I'm going to stand on a soapbox for a moment here. Frederick W. Taylor said, if you'll measure it, you'll manage it. And that was a warning. What he meant to say was, if you decide to put a metric in place, you are going to optimize your processes against that metric. Frederick W. Taylor never said, if you don't measure it, you can't manage it. He never said that because, first of all, it's not true. We do the management of unmeasurable things all the time. You have kids? I got 3. So yes, you can manage things without measurement. The other thing is that doesn't really help you make any decisions operationally. It seems to say measure everything and you'll manage better, which in fact runs against what he really said. Be very careful about which metrics you put in place. And now I'll step off the soapbox. At the bottom, we talk about the cloud migration process, and this is where you'll end up in hybrid cloud. You're going to move some stuff. It's going to go at varying rates. And regardless of which provider you use, you're going to have to make sure that you understand how your process ties into that. You're going to have to bring along the security controls and integrity and quality controls that mostly are incorporated in the ITIL library. Change management, release management come to mind. Configuration, capacity planning come to mind, as well as basic information security. So let's take a look at the next one, which is shadow cloud. Here's the problem with shadow cloud. Tech is cheap. Moore's law is accelerating. Moore's law is accelerating really fast. In fact, there are 3 flavors of Moore's law, and we'll talk about that later on. Processors improve about every 18 to 24 months. That is, at constant cost, the amount of compute power you can get doubles at an 18 to 24 month frequency. Storage costs halve at about a 12 to 15 months pace. And network bandwidth doubles at about a 9 to 12 month pace. Well, what's interesting about that is if you spin that out over a decade, what that means is that your processor is 100 times faster, your storage is 1,000 times cheaper, and your network bandwidth is 10,000 times cheaper. That's going to have implications for edge, and it's going to invite us to do things with 5G. So the point with shadow cloud, we are going to see more and more cloud coming up, taking advantage of cheaper storage and vastly improved bandwidth. It's a subset of the general shadow IT problem. There is such a thing as shadow OT, people slapping devices into places to solve local problems and thereby sub-optimizing the overall architecture. This is crucial when you're in a multi-vendor environment, when you have many digital platforms with multiple suppliers. When we talk about the identity workspace, the bringing together of everything you need with augmented reality. So an individual, say, fixing a piece of machinery can call up training on that, can call up purchasing information on which kind of parts, what kind of lubricants, what kind of substances can be appropriately provisioned to help solve this. This world is very dependent on supply chain, and with supply chain comes shadow cloud. So note that when you discover shadow cloud or transient SaaS services, that may be intentional. We needed to do that for some reason. We didn't know we were dragging cloud along with it. It may be an accident. We misconfigured something. We forgot to turn off an option. It may be a side effect of doing something that's normal every day, or it may actually be an attack. You have to be able to manage which one and what to do. One caveat about cloud. When you stand up an image in cloud, it is perfectly secure. You are the only person that can do anything with it. But as it moves through the process from initial creation in a pristine and completely secure environment to its ultimate deployment in production, many people are going to modify those configuration settings. Misconfigurations are far and away the largest security risk in cloud. And it's not that people are incompetent, it's that the configuration options are so vast. Hundreds and hundreds of settings have to be correct. There is even a profitable market for tools that help you determine if, in fact, your configuration is consistent with your security posture, if it's internally consistent. Do you really want to make this visible? Are you sure you want to make this visible? So be aware of the fact that you're going to have to supplement whatever you're doing with Zero Trust to support security in cloud with something to take a look at the configurations and integrity of your images before they go into production, and ongoing. It's not one and done. You have to look over time because attackers can change those things. Now, I mentioned that we'd be going beyond today's world, and we're going to look at edge computing and 5G and what Sassy is. Now, I already spoke about Moore's law, and here's the picture. The little box on the bottom shows the 2, 3, and 4 order of magnitude differences between bandwidth at the top, storage in the middle, and processors at the bottom. The reason this is important is because it basically tells you, due to the vast increases of bandwidth, that you want to move data to processors. You can move a large amount of data fairly quickly. Now, we can't improve on the speed of light, so the speed with which an EM signal travels through a piece of copper wire comes to about 16 inches per nanosecond. It's 11 in a vacuum. It's 16 in copper. With fiber, you get it down to about 14. But the point is that latency remains a problem. Now, when you talk about the need for data to be nearby, that's an argument for edge computing. The need for minimized latency is one of the reasons that satellites will never be important in 5G. One of the goals of 5G is to have sub-millisecond response time. Remember, light travels 186 miles in a millisecond, which means if you want to talk to a satellite, the minimum height at which a satellite can approach the Earth is not much less than 186 miles. So right off the bat, you're a millisecond away. And if you're in a geosync orbit, you're 23,000 miles away. So you are close to, large fractions of a second just to get there and to get back. So latency is a problem. Move data nearby. That's the rationale for edge. Now, those of you who remember your early database studies may recall a concept called the outer join. The outer join is, what do you do when you have a query where some of the information is here and some of the information is way over there? That's an outer join. There are two solutions. One is you wait. The second is you bring a copy of the remote data nearby. And what that gives you is rapid access to obsolete information. The speed of light and the location of information is a difficult equation to work out. But bringing stuff to edge means that stuff nearby, like the car you're driving in, the environment in which you are docking ships in a port, the logistics flow through a distribution center, these are all going to require fairly quick resolution of questions involving fairly large amounts of data. And when you deploy a network to do that, you're going to want to have your computers nearby. You're not going to want to ping something off a satellite. You're not going to want to have to send a message to another city. So edge computing is going to be a big contribution, and that is not going to replace the internet. It is not going to replace cloud. It is going to supplement it. Now, I did talk about Sassy, and here's what Sassy is: Secure Access Service Edge. And it reflects the fact that we've turned our world inside out. Things that used to occur in the data center now tend to occur more often outside it. Users do more work outside than in. Workloads running in infrastructure as a service are more prevalent than workloads running in traditional data center. More applications are consumed as SaaS than as stuff that's been bought and installed or built and installed in your data center. More critical data is located outside, and so on. The fact is that with all that information out there, we need a secure way to manage cloud. And what Sassy does is it gives us an instantiation of the zero trust philosophy that allows us to securely manage this multitude of resources that are not running on computers that we can control. So what is going on with Sassy? Well, the concept was created a couple years ago at Gartner, and since then, a number of vendors have released Sassy compliant products. Unfortunately, there's been a lot of confusion about what is zero trust and what is Sassy. So let me try to lay some ground rules. Zero trust is a philosophy. It is an architectural organizing set of principles. It has to do with how you structure the network, how you deploy identity management. But what Sassy is a particular realization of zero trust. So when these vendors say we have a Sassy compliant product, what that means is they've got a way to talk to the cloud securely, because this is cloud focused. There are specific tools and parts that make up Sassy. There is no parts list for zero trust. Remember, it's an architectural diagram, and it's got to be deployed by the cloud provider because that's where the environment is. So when you compare the two, remember that the goal is to make sure your business is secure based on both identity and also context. Context means you take a look at the risk profile of the devices, the history of the individuals, the concept of the riskiness of a potential user in an IT environment, again, is an outgrowth of network access control, but we've added stuff more recently. We not only look at the integrity of the platform, is your computer up to date with regard to OS updates? Is it using one of the approved security products? Have those security products been run with relatively current signatures and so on? Also, it will look at the recent history of the device. Has that device been offloading large amounts of data uncharacteristically? Has that device been generating a lot of email traffic that wasn't expected again or is uncharacteristic? So we're going to profile the devices. We're going to manage the risk of endpoints wishing to join networks as part of the Sassy deployment. And that's a fundamental piece of the zero trust philosophy. Bear in mind that then you cannot buy zero trust from anybody. You can build it yourself into your architecture, into your strategy. But the parts and pieces you buy, if you are going with a cloud-based version, are going to be Sassy. Now, there was one other problem that I wanted to talk about relating to cloud, and this has to do with the exercise that 5G is going to put on the cloud. Remember, one of the goals of 5G is to have massive numbers of devices. They're talking about 1 million devices per square kilometer. That is an active device every square meter in a city center. This is a lot of communication, and it's a lot of applications being created and torn down. So this is from a larger paper that talks about vulnerabilities in 5G. what we're looking at here are in a 5G world, unlike 4G, where most of the environment is proprietary and monolithic. In a 5G world, we have a multitude of devices subject to various kinds of attacks. We have the air interface to the tower. We have radio access network threats, including rogue nodes. Remember that there are going to be so many towers, they have to be deployed every 100 or 150 meters, that they're going to be cheap. A legitimate one is going to cost a couple $100, which means that the bad guys can create a picocell and deploy that, and your traffic will be hijacked. On the back end, though, and this is where the garbage collection problem comes into play, whenever you set up an application, what 5G is going to do on your behalf is they're going to take advantage of storage, virtually defined storage configurations to give you a place for that to run. They're going to stand up a stack of virtual images in which the application will run, and that will be connected to software-defined networking. So we have 3 dimensions of virtualization. The problem isn't whether we can stand up or tear down virtual images. We've done that. The problem is that when you do 5G, you're going to have tens of thousands of these transactions taking place every second. In a complex environment, as my phone moves from one place to next, as my car moves from one cell tower to the next, I'm going to have to tear down and recreate that entire virtual stack. Now, again, we know how to stand up a virtual image. What we don't know is what limits are incorporated in the technology that stands those images up. Most of us have never run a system with hundreds of thousands of creation and deletion events and run that system per second and run that system for months at a time. But the 5G network is expected to be persistent and not collapse and not need to be stopped and restarted. And so my concern is not with the images themselves, but with the metadata, with the tables, with the pointers, with the counters that tell me which image I'm standing up, where it is, where it resides, what its needs are. As we churn through those tables, as we increment those counters, as we build more and more of these lists of pointers, there will come a time when we exhaust the list. All of these counters are finite. All of these are limited in size. This is not a theoretical problem. The first instance of it was Y2K. Unfortunately, we were able to pretty much handle that with significant advanced planning. It was a foreseeable event. More recently, in March of 2019, we could see that there were some GPS satellites that were about to have a date problem. The older GPS satellites had a 10-bit counter that counted the weeks. A 10-bit counter that's counting weeks means you don't quite get to 20 years before it rolls over. And in April of 2019, those counters did roll over, and some Boeing 777s and 767s were grounded because the flight information said course is 280 degrees and it is August 19th, 1999. Can't really do that. Can't fly the plane. We've seen similar problems with HP storage devices, with certain Cisco routers, where they've rolled counters. And this is an ongoing issue. As of today, 767s and 77s have to be cold rebooted after 141 days. There are some counters that roll over, and these are in the billions. So we're talking 32-bit numbers that are rolling over. And when it rolls over, the system breaks in an unrecoverable state and has to be reinitialized from a cold start. You have to peel the Etch-a-Sketch and start over to get it going. I believe that as we deploy 5G, and this is not going to happen tomorrow, true 5G is not happening until release 18, and release 18 isn't frozen until the first quarter of 2024. So we're not going to see devices until about 3 years from now. But once we see a lot of these devices, we expect to see problems with garbage collection and with metadata corruption. So just bear that in mind. That's a 5G problem that's going to show up by impacting cloud where these virtual images reside. So what do we do about it? I have two sets of recommendations. First, I want you to make sure that you understand your processes. One of the benefits of the vast shift in where we work means that a lot of our procedures had to be made explicit. Management by wandering around allows you to get away with a certain amount of sloppiness. As a manager, you have gut feel, which is basically the combination of experience plus trained perception. You listen to your people, you understand what they're feeling, you get a sense of what their challenges are. Sometimes there are those incredibly profitable, valuable discussions where you get to know what their deep concerns are. But if you're not there, you have to figure out a way to detect that kind of stuff fairly, equitably, clearly, and unambiguously, which means what used to be done in a rather informal way now has to be codified. So you have to build those processes. You have to enrich those procedures, and then where you can, automate them. By the way, my colleague John Gerard says that as a result of this exercise, those businesses that do work on their process will be facing a productivity renaissance because they will, by documenting them, have a clear enough understanding of what the processes are that they can then go forward and optimize them. I want you to make sure that you put the right controls in your continuous development, continuous integration lifecycle, the kinds of controls that will allow you to look at changes, say, to the configuration of cloud resources, the type of controls that will verify what kinds of changes are going in and on what pace. I want you to set yourselves up to handle identity-centric security as it rolls out. This means enrich your identity management infrastructure so that you can deal not just with people, but also with things, with services, and with devices. They all have identities. I want you to perform a gap analysis on your infrastructure and operations functions. That's how do we manage our data center? And when we go virtual, what of those management capabilities do we no longer have? Amazon is not going to allow you to install a performance monitoring tool into their data center. So you're going to need to do something using whatever data Amazon gives you. And so how do you do that? And the gap analysis is not just current versus future. More importantly, it's what does your leadership think you're doing and what are you actually doing? Ask the CIO, who is responsible for this particular aspect of our environment? And if they say someone, go and ask the person, do you know that the CIO thinks you're responsible for this? Or do the two tests independently and compare lists and say, the CIO thinks that Fred's handling it, and yet Fred's not here anymore. Similarly with governance. What does senior leadership think is being done with regard to the governance of these resources, the purchasing, the installation, the retirement of capabilities, and what is actually being done? You need to make that stuff clear because the gaps are going to be problematic for you. I want you to build a software asset management database. You should have done this a long time ago. You've got to know what's actually in production. You've got to know what its provenance is. This will give you a handle on the front end of your supply chain. And this includes stuff that you build as well as the stuff that you buy, the stuff that you rent, as well as the stuff that you appropriate from open source environments. Just because something is in a very popular open source library doesn't mean that it's safe or secure or validated. In fact, Snyk, SYNK, has a tool that goes through these environments and identifies potential problems with open source software. So sign up for that. Be aware of what's going on in your software portfolio. What is your plan for retirements of this stuff? Along with that, take a look at your procurement policies. Expand those to include and cope with the vast increase in software as a service type technologies, things that are rented but are so cheap they fall below the CLIP level where procurement has to get involved. And take a look at informal buying centers. There are organizations within your company that, if it's large enough, that are actually running their own data centers by proxy. Take a look at those. Some CASB tools Some Sassy tools will tell you what technologies you're connecting to. That stuff isn't happening accidentally. I want you to upgrade and consolidate tool sets. Studies have consistently shown that people use about a third of the capabilities of the products they have installed. This isn't because people are not diligent. It's not because they're negligent. It's because at the time you bought it for a particular function, it worked and everything was fine. And you were not aware of the enhancements and extensions that the vendor put into that product every few months since the thing was purchased 3, 4, or 5 years ago. There are capabilities and tools you already have that may meet needs for functions that currently out of plan. Take a look at what you've got. Understand your portfolio. This is associated also with your software asset management database. Bring up to date not only what we've got installed, but what capabilities we've chosen not to install. As you strengthen the security of hybrid cloud, you are going to be looking at Sassy as an evolutionary step forward. I want you to pilot an architectural program with zero trust so that you understand what its implications will be for your network. And I want to make sure that as you proceed with these architectural efforts, you do so in a planned way, one step at a time. You don't want to get halfway down the road and then have a phone call cause you to put your architecture down and have it fall apart into its 1,000 component pieces. Be smart and be safe. Here's a list of references. The first one is the paper on garbage collection from John McCarthy. He was talking about Lisp in 1960. The rest are references from research organizations and NIST on cloud. Thank you very much for your time and attention.